What if I told you that deep beneath the Swiss Alps, scientists have stumbled upon something that breaks the rules of reality itself? Something so rare, so impossible, that it challenges everything we thought we knew about the universe. The mystery is called the Kaon Decay anomaly, and what they discovered might rewrite physics forever. Welcome to Sherlock Mode. At CERN, one of the world's most powerful particle physics laboratories, scientists have been hunting for something invisible. For decades, they knew that kaons, tiny exotic particles made of quarks, could do something extraordinary. They could transform into other particles through a process called decay. But this particular decay was supposed to be impossibly rare. Imagine if I told you that out of every 10 billion kaons, only one would undergo this specific transformation. That is how rare we are talking about. The mathematics was clear. The Standard Model of Physics, a theory developed in the 1970s that explains how the universe works, predicted this with near-perfect accuracy. It was a done deal. Or so everyone thought. Then came the experiment. The NA62 experiment, led by brilliant minds from the University of Birmingham and collaborators from 27 institutions worldwide. They built a detector so sensitive it could capture the moment when these rare particles transformed. They aimed a powerful proton beam from CERN's superproton synchrotron at a beryllium target, and they waited. For years, data accumulated. Millions of particles collided. Billions were created. And the scientists analyzed. They collected information from 2016 and 2017. Then they collected more from 2021 and 2022. And as the numbers came in, something unexpected happened. Something that made them lean closer to their screens. Something that made their hearts skip a beat. The kaons were decaying far more often than they should. Instead of 1 in 10 billion, they found approximately 13 in 100 billion decays. That is roughly 50% more than the Standard Model predicted. The math should not work this way, but it did. Repeatedly, consistently, impossibly. At this point, skepticism filled the air. Could this be a measurement error? A glitch in the equipment? Perhaps a flaw in the analysis? But then came the confirmation that changed everything. They achieved what physicists call 5 sigma significance. In simple terms, this means the probability of this happening by pure chance is less than 1 in 3.5 million. This was not a mistake. This was real. Now comes the turning point in our mystery. If the Standard Model is correct, and we have verified it countless times over 50 years, then something else must be influencing these kaon decays. Something we have never detected before. Something hidden. Something unknown. Physicists have a name for what might be happening. They call it new physics. Beyond the Standard Model, there could be undiscovered particles, exotic forces we have never encountered, dark matter interactions, dimensions we cannot see. The Kaon Decay anomaly might be a whisper from this hidden realm, a signal, a message written in the language of quantum particles. Professor Cristina Lazzaroni, the lead researcher, called this Kaon Decay the golden channel. Why? Because it is ultra-rare and perfectly predicted by the Standard Model. When something this rare behaves differently than expected, physicists take notice. They listen. They investigate. The Kaon Decay became their Rosetta Stone, a key that might unlock doors to new understanding. Let us analyze the clues like detectives examining a crime scene. Clue 1. The kaons decay more frequently than predicted. Clue 2. This happens consistently and with high statistical significance. Clue 3. The Standard Model accounts for the first 99.9% of kaon behavior, but fails here. Clue 4. New particles could act like catalysts, accelerating the decay process. But here is what makes this truly unsolved. The NA62 experiment is still collecting data. Scientists hope to gather enough information within the next few years to confirm or eliminate the new physics hypothesis. Every new kaon decay they measure brings them closer to the answer. Are we witnessing the first glimpses of particles that have existed since the beginning of time, hiding just beyond our perception? The universe is about to tell us. The mystery of the Kaon Decay remains open. The data continues to stream in. The equations remain unsolved. And somewhere in the depths of CERN, beneath the mountains, the detectors are listening, waiting, watching for the next impossible event, the next whisper from the hidden universe. The answer is coming. But for now, the Kaon keeps its secrets. If you enjoyed unraveling this mystery, like and subscribe to Sherlock Mode.